Okay, now we know to deal with the mass. If we have two experiments or the same experiment, we know how to deal with the force. We know its direction, we are one dimension. We can know also, or we know the distance. What is the distance? If we do this experiment twice, the first one, the second one. In the first experiment, we move our object by a force, for example, for 1 meter. In the second experiment, we move this object a distance, another distance. X2 is equal to 1.5 meters. This is X1. Physically, physics, are they the same experiments? They are the same, but there is a difference between the distances. So how can we differentiate between them? We have the same force, but the first case, the force act 1 meter. The second case act 1.5 meters. Is the action of this force is the same both experiment? The answer is not. It is not the same action. That's because we have something defined. The force with the distance. This thing is the wall in physics. It is the wall. It is the quantity in physics reflect the interaction between a force and an object to move this object some distance in the direction of that force. In the direction of that force means if we need to write our formula, the work, which is W, is equal to the force multiplied as dot product with the distance. This dot product, we talked about it, but we didn't study it. We don't need to study it. We need two vectors multiplied as dot product. This relation will give us this magnitude of the work. It is not a vector. It is a scalar. It is F, the magnitude of F, multiplied by the magnitude of X, the displacement, multiplied by cosine theta between X and F. In any question, everything will be given. So this is the relation of the work. It is the force multiplied by the distance, multiplied by cosine theta between them. For example, this is the force, and the object moved to this direction. This is the angle between them. How can we do that? It's simple. I am acting by a force, pulling force on the screen now. It is like this. This is the force, and this is the distance, x. This is the force, and this is the distance, x and f. How is the angle between them? It is 0, right? Theta is equal to 0. If I add by another force, like this, for example. Oh, not this. I'm acting like this. I need to pull it. In this case, this is the monitor, and this is my force. And this is the motion. This is the angle between them. It is not 0. Okay? Now, from this relation, I think from now on we have a limited number of pages. So you don't worry about the large quantity of material like the first part, because we do our the heavy work before. Now we have the easier things. Now the work is equal to the force. What is the units of the work? The force, it's a Newton. X in meters. Newton multiplied by meter, it is joule. The joule is the unit of the energy. Okay? So the unit of the joule is equal to Newton multiplied by meter. If I ask you, what is 1 joule? It is 1 Newton multiplied by 1 meter. Any question about it? Okay. I'm not solving examples now. I'm just talking about the work. I need to ask you, when the work will equal to 0? The work is equal to 0. The force, when the force is equal to 0, for example, if we have a weight downward, normal force upward, the total force is 0. Okay, what about the work? When the work is equal to 0? We have 3 cases. The work is a quantity. Contain inside it 3 quantities. It contains the force, it contains the distance, and what? It contains the angle theta. So we have the force, x, and theta. If any one of these things give us 0, then the work will be 0. The first thing, if the force is equal to 0, we don't have a force. Then the work is 0. For example, this cup has no forces on it, on the right and the left, but there's a weight and the number of force. The total force is 0. The work is 0. It's okay. X is 0. Now that, what is the work of the gravity on this cup? The force of the gravity is downward. For example, like this. We have a force of gravity, and there is a distance downward because the object is moving. But on the cup, there's no movement. There is a force of gravity. And the work of that force is equal to 0 because the distance is equal to 0. Also, another example, if I start pushing the wall, I am acting by a force, but the distance moving is 0. So the work is 0. The third thing, which is cosine theta. I need cosine theta to be 0. Cosine theta to be 0, then theta is equal to pi over 2 or 90 degrees. If I carry this, I cannot see it. I'll carry this. If I now I'm carrying the cup, I am applying a force upward, and I am moving like this. My force is upward. The x is to the left with respect to me. Theta. So the force is upward. The motion to this direction. Theta is 90. Cosine 90 is 0. The work is 0. If you start carrying anything like this, your work is 0. Okay, you ask me, okay, I am applying a force and I am pushing the object on my hand. From where this work is coming? I'll tell you something. This is the object and this is your hand. There is a friction force between the object and your hand. The friction force, the force from your hand is to the right. The friction force to the left. The total force, this is the applied force and this is the friction force. The total force, Fa, plus the friction force in the opposite direction will give you the motion. The motion to the right or to the left, it is coming from the friction force. Assume the object here is sliding, then you will move and the object will slide from the top of your hand. Okay. The third pair also, from the same relation, everything from the relations, physics. Sometimes the work is positive, sometimes it's negative. And people talk about if the work is positive, then the work is done by the system, by me. If the work is negative, then the work is done on me. I don't understand this point because everything will be hidden in theta, like this. If my force like this, and this is x, I have this theta. If the force like this, and x is like this, and this is theta. Cosine theta here is bigger than 0. Then the work is bigger than 0. It's a positive, it is positive. Here, cosine theta is negative. Because of that, the work is negative also, or less than 0. So you can determine whether the work is positive or negative by knowing cosine theta. If theta is equal to 90 degrees, then cosine theta is equal to 0. If theta is less than 90, cosine is positive. If theta is bigger, then cosine is negative. The work is negative. You need to be careful about the direction of the force.